Hi, thank you. I'm Dorcy Clark with the City of Dallas. I'm in the Trinity office at City Hall. And I'm basically just going to spend a couple minutes setting the stage before I hand it over to Ben, just to describe to you, for those that don't know, the recent low-impact development design competition that we held with some other area cities. So kind of just to give some background as to why we kind of embarked on this competition. At City Hall, the council had approved the Integrated Stormwater Management Manual for voluntary use at the very end of December 2009. And in that council resolution, it was very specific and said that basically we needed to go back to council after a year and tell them about the experience of who was using this, how the integrated stormwater management techniques were being used, and also to put in any local provisions. I think most of you are probably familiar with the Integrated Stormwater Management Manual. Through COG, it is a regional manual, but there's space for local provisions. So again, we adopted that regional manual. We wanted to go in and tweak and make it more specific for Dallas. So we waited more than the year that council asked, but we convened an ISWIM task force at City Hall. And it was my job, even though I'm not an engineer, to shepherd that along. And it was made up of engineers, landscape architects, and developers, really having the developers there to have kind of perhaps the naysayers on the front line to tell us where we were going wrong. And as we started working through, what are these local provisions we want to add? Do we need incentives to get people to be using these green infrastructure techniques? And, what are those examples that have been done to date at the City of Dallas so that we can learn from them as a task force and also to relay that to council? We really realized that, unfortunately, there wasn't a lot that had been done. And we kind of went through a quick analysis as, since late 2009, the economy wasn't so good. Perhaps it was just that there wasn't a lot of development. Perhaps it was just the engineers doing work as they had always done. And despite the fact this manual is there, maybe we weren't educating people on it. There wasn't enough exposure. There wasn't enough trust that these green infrastructure techniques could be used well and be used cost effectively. So we looked to Houston at that time and said they just completed this design competition. And we think what it'll give the City of Dallas is all of that experience that we need. It'll give kind of the buy-in, the exposure. It'll get the professional community, all the consultants out there really thinking about this and having good demonstration sites in which we can look at and again show City Council. So as we were kind of muddling through, figuring out, from everything we read from Houston and started talking to them, that this was a pretty big task. And this isn't my only job at City Hall, so I was like, okay, this seems like it's going to be a full time. So we were approached, and very thankful to be approached by the Land Water Sustainability Forum that had done the Houston competition. They came to us and said, let's do a North Texas forum, and let's do this regionally. And we said, that is fantastic, then we're not the only ones looking like we're putting some new burden on the developers. And so we joined forces with the cities of Arlington, the city of Fort Worth, with COG, and with the forum to create this design competition. We ended up getting 4 demonstration sites, the Arlington Library, Fort Worth Northern Crossing Project, and 2 in the city of Dallas, Cedars West redevelopment near the Trinity, and South Lamar, which Ben's going to get into in a little bit. We're really excited. We had 20 integrated teams. When I say integrated team, every team had to have engineer, architect, landscape architect. So that was from 55 firms throughout the region. And there was 2 different judging sessions. The first judging session was held last September, and it accounted for 80% of the total score. And those were the real professional experts in understanding this stuff. And so that was a really neat day of getting through all of the consultants' work and kind of seeing which ones rose to the top as finalists. And then in November, I think some of you guys went to our big finals event. There were approximately 350 people, but the judges at that event they did a lightning speed 7-minute presentation to get through everything. There were 20 judges at that event. And what was neat there is the judges were the city managers, the council members, developers who may not have been interested in this before, and a bunch of big organizations like EPA and stuff. So that was a really, really neat event and brought a lot of exposure. And I think I can say with a straight face, if it wouldn't have been for this design competition and that big finals event, then I don't think that our RFP for our complete streets would have looked how it did. I think that that was really the catalyst that said, we need to have a category of experience in that RFP for green infrastructure techniques and how well these consultants know that information. So I think that is it for my piece, and with that, I'm going to hand it over to Ben to talk about South Lamar, which was one of the city projects. They were the winner in this category, and again, this was one of the city's 2012 bond projects that we are currently moving forward with.
Thank you, Dorcy. Like she said, my name is Ben McWhorter. I'm with Freese and Nichols in our Dallas office. I work in the stormwater group in Dallas. This competition, just to kind of start out, was a really cool opportunity, especially for a young engineer like myself. Where Freese and Nichols gathered a team of people all within just our company. We had an opportunity to branch out and team up with other firms, but we decided to just try and do everything in-house. And so we selected a team that I was a part of, and they just kind of gave us free rein to take on some new concepts, to take on some innovative approaches to traditional design. And it was a really cool opportunity that I'm thankful to have been a part of. We lose speakers again? Sorry. Okay. Thankful to have been a part of it, and I'm just going to tell you guys a little bit today about our South Lamar design for South Lamar in Dallas. For those of you who may have seen this presentation before, I've added some new things in, so keep your eyes open for some interesting new bits. And if you have any questions, I don't know if we'll have time at the end, but I should be around afterwards. Feel free to stop me then if you'd like to ask any questions. So the competition goals that were given to us are on the screen. They're really generally aimed to focus on conserving natural resources, minimizing costs, and overall just enhancing quality of life within the redevelopment. And these goals were consistent across all 4 project areas. So we approached these, and you'll notice through the presentation when I'm talking about various things, these blue boxes will be in the corner that kind of explain how we achieve these goals in different components of our design. We wanted to also add in one other design measure into our project, and that's the site-specific benefits. One thing we understood going into this is, just like traditional design, you can't approach every project in low-impact development the same way, and not every solution is going to work out exactly the same every time. And I think even more so when it gets into the low-impact stuff, based on what your site already has on it, what type of use it's going to, or what it's going to be used for. And then just certain limitations that kind of hinder the ability to just completely wipe the slate clean and go all green. So you have to really focus in on the site at the very beginning, and that's one really cool thing about this project is this is the very first design phase of South Lamar Street, and so we're looking at it from the very first perspective, and this goes on just like with ISWIM with your preliminary meetings, where you're talking about drainage at the very beginning, and that's what we're approaching on this project, and I think it's going to end up coming into some really cool solutions for the future. So South Lamar Street, here's kind of a view of South Lamar in existing conditions. You'll see on the north side of Lamar, which is the blue line going down the middle, is all residential. There's actually some historic residential areas there. And then on the south, just across the street, is currently industrial with a little bit of commercial. So it's a 4-lane road, partially divided, partially not. But the Trinity River Vision future zoning has all that industrial rezoning into commercial. And not only that, but it's going to bring the North Texas Tollway through that development straight through our project area. And then it's also going to bring, you'll notice a green dotted line up there. That's a future pedestrian connection to the Trinity Trail system. So there's going to be a lot of added traffic to Lamar Street, maybe not overbearing vehicle traffic, but there's going to be a lot of eyes on this area, and it's going to redevelop very quickly when this all starts coming through. And so Lamar Street, we kind of view it as a gateway for that redevelopment and kind of a first foot forward into redeveloping the right way. So I want to kind of go through some photos of existing conditions on Lamar Street. This is historic Borden plant, and if you look, that's actually located on the far right side of the screen at the very end of the project area. That thing's been there a long time, and it's got some really unique history to it. So it's something we wanted to incorporate into the project. Also, as you can see here, this is a view from the residential side of Lamar Street, and across the street is that industrial area. And you can see that there's that tall kind of noise wall, and then outside of that, they've tried to increase the aesthetics a little bit by adding some artwork and some trees. And so you can see that there's already a desire to have a buffer between the residential and the industrial area. But for the most part, this is what Lamar Street looks like. It's a very impervious right-of-way. In most cases, I would say from edge of right-of-way to edge of right-of-way, it's completely paved. So there's a lot of on-street parking. There's a lot of truck traffic that goes into that industrial area. So there's not much room for water quality. You got a lot of pollutants running off of this area. And then on top of that, you've got really outdated infrastructure. So we looked at a lot of the as-built we looked at for this project were dated back to the 30s and the 40s, and they're still there. And that goes to show that while the system's there and it may be maintained properly and may be functioning the way it was designed, it may not be functioning the way it needs to be for the way it's developed now out there on Lamar Street. And so that's just something we noted going into it. We've got a lot of dated infrastructure from the storm drain, but also from the roads and that type of thing. So going into our design a little bit, this is just an aerial view. It's kind of hard to see, but you can tell what I'm talking about with the right-of-way paved all the way across. And the standard design that we would do is come in, just bring in a divided roadway, 4 lanes with a raised median, 5-foot sidewalks right up next to the road with not a lot of green space. But we kind of looked at it, and one of the goals for this was to minimize imperviousness and kind of minimize the quantity of runoff we were creating. So we wanted to maximize our green space, and in order to do that, we shifted the roadway to the south of the right-of-way. And opened up, by doing that, we opened up a whole lot of green space on the north side to do some pedestrian amenities and also to facilitate our stormwater quality treatment controls. So we also kind of approached Lamar Street from the complete streets perspective and added in some on-street parking. We've got some bicycle routes and wide bus lanes on the outer edges. And as you can see there, and we'll get into it a little bit more, but the bioretention basins are used for the water quality treatment are right off the top edge where you see the dark green space. That's where we'll actually drain water conceptually at this point. That's where the water will drain across the road and filter there before going off into the storm drain and then right into the Trinity. So also we've got, going in more into the pedestrian amenities, we've got the handicap accessible, everything's handicap accessible, and we've got the stained crosswalks. One cool thing about this area in the future development is that it will become kind of a gateway for the Trinity River as well. And there's plans for kind of a logo to stamp the area with. And so we've kind of facilitated for that in our design to allow whatever that logo ends up being will be incorporated into Lamar Street as well. Go ahead and move on. The historic Borden plant that I showed you is just one of many really cool historic amenities of South Lamar. And so while it's not necessarily a low-impact design measure, it's kind of the holistic approach to redeveloping this right-of-way. And to do that, we wanted to try and increase neighborhood pride, try and increase, just bring some education to the area about the history of the South Lamar area, and to do that, we propose to add some historic kiosks next to the bus stops. In addition, we want to use LED lighting for all the street lighting as well as the pedestrian lighting along the pedestrian trail. This will obviously conserve resources and kind of lower the maintenance requirements for the area. So now getting into the engineering portion of a little bit, where I'm a lot more comfortable and not so much in the urban planning. I will say for all that urban planning and design stuff, we have a team at Freese and Nichols devoted solely to urban planning and design. And so Lane Wheatley was kind of the manager of this project, and she kind of took charge of all that. Basically everything that I just showed you was part of that urban planning that we approached it from. But onto the engineering, we looked at the pavement design, and you can see a cross-section of our proposed road on the screen right now. One thing I want to point out is that the roadway is not crowned. It's super elevated all the way across, so all of the runoff from Lamar Street is going to drain to the north, where we'll collect it in those bioretention basins. And I'll show you a little bit more about that in a few minutes, but I want to point that out in the cross-section. One other thing that we went for as far as a low impact away from the drainage was simply the way we designed the pavement and the roadway section. So we proposed all recycled materials for the pavement and the base, and then we want to reuse the reuse the existing asphalt as a bonding layer. And then on top of that, we did propose to use something called moisture treated subgrade. If you're not familiar with that, it's simply just a way of treating the subgrade beneath the road to try and eliminate some of the differential settlement that can be caused in the clay soils. Depending on the true condition of the existing soils out there, this has the potential to increase the life of the pavement by at least 10 years. We're using it on another project that we're doing right now, where the soils called for it, the geotechnical exploration suggested using moisture-treated subgrade. So this is something that we suggested for this project without a lot of background information on the soils, but if necessary, as close as it is to the Trinity, it can be a real benefit to the project. So now onto the drainage, where I'm even more comfortable. Like I said, I'm in the stormwater group, so this is what I do. For low impact development, we're approaching drainage from two perspectives. We want to reduce the amount of runoff we're creating, and we want to increase the quality of runoff that is present on the project. So just a quick overview of the Lamar Street watershed. You can see Lamar Street in the black and white dotted line across the screen. And you can see it's on the downstream end of this 185 acre watershed. So there's a lot of runoff that comes to Lamar Street. Looking up, and I don't know if you can see it very well, but there's the bright green lines throughout there are the existing storm drain system. So it's a pretty extensive system out there existing. We don't have a whole lot of information on it, or didn't have a whole lot of information on that system going into this design competition. But one thing you can think of from a water quality perspective is, and the one thing that we were kind of flabbergasted by when we first started, is how are we going to treat, within the right-of-way of Lamar Street, how are we going to treat 185 acres worth of runoff in this small area? And there was a small hiccup till we decided that we didn't need to treat the entire 185 acres. In order to do that, honestly, the entire residential subdivision would have to be redeveloped in a different manner, or there would need to be some sort of large detention facility with water quality features to do that. So we wanted to take a closer look at what we could handle, and that's just what's draining within the right-of-way. So you can see the drainage in the Lamar Street right-of-way is roughly 7% of the entire drainage area. It's a very small amount, about 13 acres. So we took a close look at it and designed it to three main design points, A, B, and C, that you can see on the screen. So to go back to our discussion of reducing imperviousness and just reducing runoff, what we tried to do is, like I said, we tried to maximize our pervious area, maximize our infiltration before we even got anywhere close to designing structural controls to treat our stormwater. And in doing this, we were able to significantly reduce the amount of water quality volume that was to be treated for the project. So here's just a quick view of one of the design points that I showed you. Simply based on reducing the impervious area within the right-of-way, in the 100-year, at this design point, we saw about a 17 decrease in peak flow rates. Just from redoing the right-of-way, we've removed the median and increased that green space quite a bit. While there are de-soils, there are very low infiltration rates in the soils, we're still able to significantly decrease the runoff from within the right-of-way. Moving on to actually treating the water, there's really three approaches in ISWIM, which was our requirement for this project, to treating water quality. The first option is to use the integrated site design practices. So this is simply to preserve environmentally sensitive areas and riparian buffers, reduce imperviousness, and maintain infiltrative capacity of the soils. Well, first of all, we didn't have any environmentally sensitive areas in our right-of-way. But like we already talked about, we significantly reduced the imperviousness. And then finally, like I said, we didn't have any high infiltrative soils on our project area, so we weren't really able to preserve those and use those for infiltration. So we had to move on to the next step, which is to use structural controls to treat the water. ISWIM defines this a little bit differently than the competition requirements, but the competition required that we remove at least 80% total suspended solids of the first 1.5 inches of rainfall. So what we decided to do, and we've done a couple of different things on different projects that have either been constructed or are being constructed, but on this one we really wanted to try and use bioretention basins to treat the water quality. Now, bioretention basins significantly exceed the requirements of the competition. They actually remove, it's tested about 90% TSS, and they also remove other metals. But we kind of thought with the proximity to the Trinity River and just the high pollutants that are going to be found because of the industrial development, we thought removing even more than 80% TSS was appropriate. So here's just a quick plan view of our conceptual design for the bioretention basin. As you can see, like I was showing you in the cross section earlier, we've got that road super elevated, and so all the drainage is going to the north, to the top of the screen as is shown here. It's traveling right now conceptually through those curb cuts, as you can see, and then into the bioretention basin, which is just a vegetated depression with some engineered media beneath it. And it'll collect and filter the first 1.5 inches of rainfall, and will be designed so that after that 1.5 inches, we'll fill up the basin to a certain point, and then all the extra, so any storms greater than that, will be released through an overflow inlet. So as you can see, I don't know if I have a pointer. Yeah, here we go. So this blue line right here is basically a box that will collect the filtered water and provide positive drainage to go out towards this junction, while all the other runoff that ponds in this area exceeding 1.5 inches will be drained out through this overflow inlet and then out to an existing or a conventional storm drain system, and then to the Trinity River just to the south. So like I said, we teamed up with various departments within Freese and Nichols, and one of those departments was the landscape architecture department. We've got some very knowledgeable guys over there that were able to help us select all these plants. These are the plantings we selected based on their attributes. Now, I can't tell you much about them, but I do know that they are all, we select them to be drought tolerant and also inundation tolerant. So with these plantings, there's about a 2-year establishment period where they do need irrigation, but after that, they are native plants which hopefully would not require any irrigation in the case of a drought. But they also, as the bioretention basins pond up, these plantings are also inundation tolerant, so they won't be killed in the case of a storm with that ponding. Not only do they do that, but they provide a very aesthetic appeal to the area. As you'll be able to see on our last slide, they really increase the vitality of the area when you start planting these and using them as your infrastructure. So one of the goals of this competition was to go through at the end and compare our costs of the low impact design to a conventional design. In doing that, we used some guys in our construction services department to help us develop that cost estimate. What we found was an initial 8% cost savings for the low impact design versus the conventional design. But then we started looking at some of the components of our project are going to increase the life cycle or decrease the life cycle costs of this low impact. And so we looked at the pavement repair costs, landscaping maintenance, lighting maintenance, and just the overall design life of our project. And we're able to find a 17% per year cost savings for the low impact design versus the conventional. So we're all now very well versed in professionals in the Envision rating system because of this morning. And so I wanted to throw this in and just talk about, we had a verifier check our project using the Envision rating system for all 5 categories: quality of life, leadership, resource allocation, natural world, and then climate and risk. And at first our scoring wasn't that great, but we kind of went back through our project and redid a few things using that Envision rating system and just the ideas that it presents. And we were actually able to boost our rating up to the platinum level for this project. So real quickly, I think we'll have a little bit of time for questions, but this is a before photo of South Lamar Street in existing conditions. And so you can see, once again, the high impervious cover within the area, and you can see a lot of traffic, and it just, to me, that just screams stormwater pollutants. But moving on to our vision for South Lamar and incorporating all these design elements that I've just discussed with you, we've really changed the area and changed the look of it, changed the overall purpose and the usability of Lamar Street. And so promotes safety in all modes of transportation. We've got safe travel for pedestrians, bicyclists, bus traffic, and vehicle traffic. We've also got a way to increase neighborhood pride. We've got just an increase in quality of life all around. So that at the end of this competition, where the finalists event, there were three teams that presented on that day, and I think all 3 teams had similar thoughts for the area, which just goes to show that just because it's a new adventure to go down, a new way of designing things, doesn't mean that it's going to be different every time. It doesn't mean that it's not doable. And it really impressed me with the other teams that competed in this, to see the designs that came out of that and how everyone, even though they had their own quirks, their own differences, every submittal was feasible and it was doable. And I think every submittal also came in under conventional costs. So that was something that really stuck out to me about this competition, and I'd love to answer any questions now if you guys have any.